Solving a quadratic inequality written in factored form. This is a nice warm-up to get us feeling about algebra, as well as to remind how inequalities, intervals, and the like work. So let's just dive right in, solve the inequality, and write the solution set in interval notation. X plus 4 times x minus 3 is greater than or equal to 0. There are a couple of things that make this problem very convenient for us. The first and most important is that the right-hand side of the equation, or of the inequality, is 0. If the right-hand side were anything other than 0, we would have a problem. The next really useful thing is that the left-hand side is factored into two linear factors. Once again, that makes our life an awful lot easier, so we're really happy to see those things. When we're trying to solve an inequality, specifically when we have an inequality set at 0, one of the nice properties of algebra is that as long as the expression we're dealing with is continuous, and pretty much everything you look at in this class is pretty much continuous everywhere, then the only way you can get from greater than or equal to 0 to less than 0, or from less than 0 to greater than 0, is to pass through 0. So we can solve this inequality by looking at the critical values, the places where that inequality becomes an equality. From here, we can look at the two factors individually using the zero product rule. Usually we would put or there, but because we're looking for critical values, these are all critical values. All right, so we have critical values of x equals -4 and of x equals 3. Right, I'm going to go ahead and copy these things over onto a new page. All right. So we're still looking at the inequality x plus 4, x minus 3 greater than or equal to 0. We have our two critical values, x equals -4, x equals +3. The next thing we want to do is sketch out a number line and plot those two values on the number line. Then from here, we can pick some values kind of around these. Because again, the only way we can go from greater than to less than, or from less than to greater than, is to pass through equals, which means we have to change at these critical values. They are the only places where this inequality can change from true to false. So we pick things around those values, like say -5 and 0 and +4. And we test the inequality at those values. So if I plug in -5 for x, that's looking at -5 plus 4 times -5 minus 3, which is -1 times -8, which is +8, which is in fact greater than or equal to 0. So -5 works, which means that everything in this region with -5 will also work. Then we try 0. Right? Unfortunately, when we try 0, it doesn't work. And since 0 doesn't work, nothing in this region between -4 and 3 will work. And then finally, we try something bigger than 3. We'll plug in 4. And when we plug in 4, we once again get something that is in fact bigger than 0. And since something over here worked, that means that everything over here will work. That will be part of our region as well. At the endpoints, we had greater than or equal, which means that if I plug in -4, well, that will make this first factor 0. 0 times anything is equal to 0, and equal to 0 satisfies the inequality. So -4 works. We put a big filled dot in there to represent that that's going to work. Same thing at 3. So there is the graph of our solution, which is an important part of the process. And in some of the problems that you're looking at, that's where you'll end. But for the sake of completeness, I'm going to copy that onto one more sheet and just use this to remind you quickly that once you have a graph of an inequality, you can rewrite that in interval notation. This particular graph goes off forever to the left. That's represented as -infinity. It goes up to 4. 4 is included, right? We use the parenthesis to say the value is not included, and infinity is never included. We use the square bracket to say that the value is included. We use set union to represent a gap in the graph. And then over here, 3 is included, so we use a square bracket there. Goes off forever, that's positive infinity. And infinity is never included, so we use a parenthesis there. One of the nice things about interval notation is if you choose to use the word infinity or an abbreviation, INFTY is a very common abbreviation for infinity because mathematicians are lazy and just putting those couple of extra letters in is way too much work for us. But by thinking about things like that, you can type an interval into a computer, which really makes it a lot easier to talk about things. A graph certainly is not something that you can directly type in unless you have a nice interface like we have here in ALEKS.